Good morning. Thank you for joining our webinar today on infrastructure as code. Some quick housekeeping. If you've never used Zoom before, please direct your questions to the Q&A section. Leave the chat primarily for things like maybe you have audio issues or video issues, but the Q&A is where we will answer questions. You also have the ability to upvote other questions from attendees. So if there's something that someone else is posting that you think is relevant to you, please upvote it. And the question will either be answered in the Q&A or will be answered at the end live. So my name is Cody Green. I'm a cloud architect with F5 Networks. I primarily specialize in helping customers move their applications to public or private cloud. I've been with F5 for about 7.5 years. Before that, I spent most of my career in development and operations, kind of moving between the two. Today, I'm joined by Ted, Scott, and Vince, all senior systems engineers with F5 Networks that will be our panelists today, helping answer your questions and providing input at the end. So with that, we'll jump into it. So what we're all here for today, right? The agenda, we're going to talk a quick overview about infrastructure as code. And some people are saying they can't see me. All right, well, we'll just keep moving forward. F5 automation toolchain, this is how F5 will leverage some of our declarative APIs to enable infrastructure as code for you. And then infrastructure as code using Terraform and F5. So quick overview. Some of the key market trends that we've seen with our customers are the desire to execute at the speed of software. Well, what do we mean by this, right? Moving away from the times, the SLAs that it takes to deploy using a standard ticketing system, right? We're all familiar with this. Maybe it takes a couple of hours if you're lucky in your environment to deploy a big IP. A lot of the customers I work with, they have a backlog. Right? Maybe they need to deploy a big IP virtual server, but it may take 6 weeks. And what a lot of people don't understand, it's not specifically the F5 that takes 6 weeks, it's all the interdependencies that the F5 needs. So things like SSL certificates, things like DNS or IP management, and all of these have to be automated. What businesses want to do is change quickly, right? They want to be able to start leveraging app capital and take advantage of everything that they can do through new applications and new revenue streams. So to enable that, we have to be able to deploy at computer or software speed and not fail to human speed. Changing customer behaviors and new expectations. Right? So everything on demand, right? Call this the prime syndrome. Everyone wants something and they want it immediately. Now, this is something that your public cloud providers have really been able to embrace with your customers. And when we look at the capabilities, a lot of times the customers I'm working with are choosing public cloud, not because the features are better, right? When you compare some of the firewall capabilities to things like Checkpoint or Palo Alto, or you compare the application security capabilities versus products like F5, they are not an apples to apples. In many senses, they're many years behind. But what they are giving those users or those developers is speed. They're giving them convenience. And so they're choosing that over security or over feature sets. What we want to do is help enable you to give your DevOps or your SRE teams the speed that they're looking for and the ease of automation, possibly easier than what they're doing with cloud native, but making sure that we're able to get that on-demand or one-click type of deployment. And then finally, rapid change in business models, right? New ecosystems, new values. If you haven't seen the F5 App Capital presentation, I highly recommend it. It talks about the trend that we see in organizations where you're moving away from your capital is primarily driven from maybe a standard service to where applications or APIs are driving a lot of revenue for customers, and it's where most of their operations are moving towards. And what we want to do is help ensure that you're able to take that migration and do it successfully and not suffer from outages or security vulnerabilities or flaws because you're choosing speed over capability. Now, all of that wrapped up basically means that it requires a successful and flexible automation strategy. This is some of the things that we talked about in the first webinar. So if you're new to this series, it's a 3-part series. The first was automating big IPs with Ansible. The second is focusing today on infrastructure as code. And the third, which will be next month, is focusing on tying it all together in a CI pipeline. Now, these videos are recorded. The code and the presentations are provided up on GitHub. So don't feel bad if you didn't catch the first one. You can catch up at any point in time. And please feel free to ask questions along the way. So you've all seen various iterations of the DevOps continuous integration cycle, right? When we look at this, there's a lot of different components that we may belong to, but one of the areas that's missing or that most organizations are struggling with is the operations portion, right? Their developers are moving quite along, building, integrating with CI pipelines, but it's building out the operations, the infrastructure that a lot of them either choose to move on their own pace or do their own thing, or the traditional operations teams are kind of left behind. F5 created our Super NetOps training about 3 years ago, and the goal of this training was to help operations engineers and security engineers really start to embrace DevOps. So it's a 3-class system. That is, the first class is focusing on teaching operations and security engineers how to work with APIs. So like any good training program, we walk you through a long drawn-out process, imperative models, we'll touch on in a minute, and what you're doing is building out systems. We then let you go on a coffee break, and like any good training system, we come back and show you how to do it in a single API call, right? This is what we're really after and trying to help our customers enable operations and be a contributing member to DevOps. So where does infrastructure as code fit into this, and why would you do infrastructure as code? Well, one of the big avenues that customers are looking at is cost reduction. Right? I work with some customers that have 12 or more engineers, and all they're doing is application deployments. Right? What we want to do instead is really have those 12 engineers focused on what changes the organization, what helps drive innovation, what helps drive revenue. And dealing with the knob turning isn't necessarily driving that today. So what we're enabling them with our Super NetOps training is to start automating some of those processes so we can free them up to do more exciting things in their organizations. And then focusing engineers on higher level tasks. The other big thing is outages cause a substantial revenue loss for customers. I worked with a customer that, even small outages could result in a particular app up to 20 or 30% of their revenue. And this is things that had maybe 1 or 2 outages a year. What we want to do instead is use automation or infrastructure as code and automation to reduce the cost suffered from those outages. Now, speed increase, right? This gets back to what we talked about earlier in the ability to move at software speed. We want to deploy apps and infrastructure on demand, and we want to enable those teams that are driving these applications or this innovation to do it on their own. We also want to mimic what the cloud providers have given us. As I mentioned earlier, right? There's not a wrong or right way. Some services work better or work fine with cloud native capabilities, but for a lot of our customers, when they're looking at things like security, right, the cloud native capabilities just aren't there yet. But why they choose cloud native is because it's easy. Let's give them, or your users, the ability to have the security that they need, but the ease of deployment along with it. And then finally, risk reduction, right? This one's pretty obvious to most of us. We want to reduce the human errors that go along with configurations. I've been in IT for over 20 years. I'm guilty of this, throughout every aspect of my career as a developer and in operations. Inevitably, you make mistakes. But if we can use automation, then I can now guarantee that when I deploy into my dev environment, when I deploy into my QA, when I deploy into production, those environments are all identical. And hopefully, if there's an error in my code or my automation, we're finding it in that dev environment, not in production. The other thing is we can build security innately into our products. What I mean by this is instead of security being something that's slapped on at the last minute, security becomes part of the development process. Now, because everything is infrastructure as code or it's automated, the dev team, when they're building out their environments, are able to actually test with your security stack in that environment. And then this leads into the integration with the CI pipelines. Now, we'll dig more into integration with CI pipelines, kind of tying all of this together in module 3 of the webinar, which will happen next month. So there's 2 main approaches. Many of you are like, wait, we've seen this, right? But what we want to do is make sure this point really sinks in, because this is important when we talk about automation and orchestration. The imperative versus declarative models, right? Imperative is telling the system how to do something every step of the way, right? So this is the equivalent of telling a chef how to cook your meal. Now, there's advantages and disadvantages to this. One of the advantages is imperative can actually be pretty easy to get up and running. A lot of organizations will start with imperative processes because it's what they know, right? If you're an F5 engineer, you know the process of building a node, then building a pool, adding the node to the pool and such to actually get the end result. However, if I'm an application developer or I'm an automation engineer, I may not necessarily know the intricacies of the F5 and that this needs to happen before that, right? And so this is why we see a lot of teams struggle when they start to get to many levels or many variations of automation, right? Different types of apps. Or when we talk about things like, how do I actually enable a team to really do their own thing with infrastructure as code? For most of you that have heard of our F5 PerApp VEs, this is becoming a very popular model, and it's no different than what you see in cloud native. This really starts to enable those operations or these DevOps engineers to deploy their own environments. So we have to kind of move past imperative and actually move to declarative. And declarative tells the system what you want, right? What's the end state? I don't care how you achieve it. And so what we're really referring to here is the equivalent of a drive-through. You pull up to a menu, you order a burger. Between that menu and the window, you don't necessarily care how the burger is made, right? We just want the burger that we ordered, and we want to make sure that it's the way that we ordered it. So declarative APIs help you define the desired end state. It fills in the details of how to get there. So declarative APIs are very powerful and really the preferred model when we talk about infrastructure as code. Now, some additional benefits when you talk about declarative models against the big IP, right? It minimizes the number of TMOS domain expertise that's required. Also, it increases the speed from the development time. What we mean by this is I've worked with organizations that have been playing around with automation for quite some time. Being able to come in and show them things like our Application Service Extension, AS3, and get an app up and running in under 30 minutes is extremely powerful. They may not have been able to do that with imperative processes because they're having to essentially build Lego blocks, right? And that's where imperative does have benefits, is that it can work in brownfield type of environments, but a declarative just simply says, hey, tell me what you want and let me do everything to get you there. It requires few API calls. So this is important because like I mentioned in the training, if I have 300 plus API calls to actually bring up two big IPs and cluster them together, right? Something could go wrong. Maybe I call the wrong API in the wrong order. If there's one API call, right? This is the power of declarative. I'm taking all that domain expertise off of you and I'm handling it. It also, when we talk about F5 declarative APIs, it's the first time that we have offered schema contracts. And we'll get into more of that when we talk about the automation toolchain. The other thing I'll touch on is easier integration into automation tool systems. So when I work with a customer and they say, hey, we're using Ansible, we're using Salt, we're using Puppet, we're using Chef, we're using something my kid wrote last night, I always say, yes, we can integrate with it. Why? Because it's a single API call, right? This makes it very trivial to integrate with any solution that's on the market. When some vendor or engineer goes off to a conference and they see the next shiny new thing, and they come back and say, hey, I want to use this. Well, declarative APIs make it easier for you to go, okay, we could play with that, right? We could see if that's a benefit to us, versus looking at it and going, man, I've got to retool everything I built, right? We want to move away from those models. And we learned that firsthand by writing imperative modules for various components like Puppet. And then realizing some of our large customers who wrote the module for moved on to Ansible. Right? So let's make things agile as much as possible, and declarative APIs give us that capability. Now, there's two methods that we typically work with when we're talking about infrastructure as code. The first is push configurations. Well, this may seem obvious, right? What happens is the orchestration or automation tools pushing the config onto the big IP. Now, the pull is where it's a little bit opposite. The infrastructure is now pulling the configuration off of some type of master node. Now, there's no right or wrong method. Ultimately, it really depends upon the automation tool that you're using. However, you'll see F5 typically leans towards the push configuration because it doesn't require any type of agent living on the big IP. And we're able to do a lot of our automation in a disparate type of environment. What I mean is I don't require master nodes. Pretty much if I can install Terraform or Ansible on a box, I'm good and ready to go, which makes integration with CI pipelines very, very easy. But again, there's no wrong method. If you happen to be using Puppet, right, we have capabilities to work with Puppet and a pull type of method. So use what's best for you. In these demos, though, we're going to use push. So tools. For those of you who saw the first webinar, we talked heavily about Ansible. Today, we're going to talk heavily about Terraform. You may be saying, well, wait, right? This is the infrastructure as code. Weren't we kind of doing this in the first session? And you would be right. Ansible is a tool that can do infrastructure as code. Why I differentiate the two is Ansible is a great product at configuration management. When we talk about the templating engine, Jinja 2, right, there's a lot of power behind that and how I can dynamically change what my declarative statements need to look like. Terraform, on the other hand, is a great orchestration tool that provides a powerful state management system. So what this allows me to do is really store my state, either be it in local or preferably in an S3 bucket, in GitHub, or even things like Terraform Enterprise. Now all of my team members can work together when we're deploying our infrastructure. This may not seem critical when you're talking about like a single developer, but when you're working in a large team, this becomes very important. So I don't think that it's going to be one tool versus the other. And you'll see this in the third seminar, right? We will use both tools in our CI pipeline. And I think that's where most organizations are going. If you'd like more information on Ansible versus Terraform, or more importantly, using them together, I highly recommend you check out Linux Academy's blog, linked below, for more information. So the F5 automation toolchain, right? For us, this is the heart of how we tie all of this together. For those of you who have not heard of the toolchain, you may have heard about the individual components, but the toolchain is just pretty much the, grouping all of them together. And what they provide is a free tool to help you configure and deploy your big IPs using declarative APIs. Some of the individual components are our cloud templates. So in AWS, these are our CloudFormation. In Azure, these are our ARM templates. We also have templates for GCP. And these allow you to do that initial deployment. Now, there's a key differentiator, right? Some of the things that they'll do is deploy the big IP, but they may not license the big IP, and they may not cluster big IPs. This is where declarative onboarding comes into play. Now, declarative onboarding is fairly new. It's been out for a couple months, but it gives us the ability now to provide a declarative API to tell you what the F5 should do. Things such as licensing. I mentioned before, over 300 API calls to cluster two big IPs together. A declarative onboarding does it in a single API call. So it makes it very easy to do some of the base level operations for the big IP in your environment. The next is some of the things you may already be familiar with, AS3, right? This is the way that we provide a declarative API to deploy our applications, but giving you the ability to add on things like app security, the ability to do things like service discovery, and the ability to do things like configure DNS, or global availability. Now, for those that are new to the automation toolchain, all of these are iControlX extensions. So typically they are installed on the big IP itself, or they're installed in containers. Now, we have an API services gateway that allows you to deploy these all together, either in a container or in a VM platform. And this just really helps separate that automation from the application or the big IP in the environment. And then the telemetry streaming. This is where we're able to provide the feedback loop to the app teams. So giving them things like application telemetry, application data, and putting it into systems like Kafka or AWS CloudWatch. And this allows them to take action on things that are happening in their environment. Maybe the environment is over CPU. Maybe the memory is being leveraged at high levels. Maybe throughput is beyond what they would normally like. This gives them information so they can take action, whether that be scaling or redistributing traffic globally. Now, what we all came here to see, right, is, well, how do we tie this together? How do I actually achieve this? So in today's examples, all of this is being published on GitHub, so you can definitely follow along at a later point. The video is being recorded, so you can use that as you walk through. But what we're deploying is a simple lab inside of AWS. It's a single availability zone deployed in East 2. You could, of course, change that. It's very easy by a variable. We're deploying a security group to only allow management from your public IP address. Now, why is that? This particular big IP is being published directly to the internet, and so we don't necessarily want anyone other than you to be able to get access to it. Now, we are building out security groups to allow HTTP and HTTPS traffic from anywhere so that you could actually publish an app and test it from different devices. However, if you need to lock that down, feel free to use the same type of policies we're doing for the management security group. And we're deploying a single instance big IP. This is a single NIC, and what this means is that the management interface will move from 443 to port 8443. All of this is taken into account inside of the Terraform code, but it's important for you to know if you've never used it before, it's a single network interface. There's not a separate management interface, so you will actually access management over port 8443. This is a 25 megabit image, and we're licensing using the marketplace, so pay as you go. If you would prefer not to use PayG licensing, then you can easily choose a separate AMI and then define the license inside the declarative definition. For the app, I'm using an F5 demo app that lives in a Docker container. We're going to deploy an ECS cluster, and we're going to use 2 Fargate instances running the demo app. The reason I'm choosing Fargate is I don't have to stand up any EC2 instances. I'm using compute that's available from AWS, and it kind of reduces my cost because typically this is up and running short-lived. I don't want to spin up an entire EC2 environment other than my big IP. So let's dig into this a little more. So for those that are new to Terraform, just a quick overview, right? Why Terraform? Well, for me, it gives me the ability to define infrastructures and the goal of that end state, but manage my planning and deployment separately and repeat that deployment across multiple environments. Now, what do I mean by this, right? Some of the key benefits are the ability to see what changes will be made with the plan. Now, that may seem odd if it's just me, right? I should know what's changing in my environment. But a lot of times you're going to be working in a team of multiple people. I want to be able to see what effect other code commits have done to my infrastructure. So maybe someone's changing the instance type that we're deploying the big IP on, right? I can see that when I run a plan or a Terraform plan to see what's going to change. The state management is really one of the things I like about Terraform versus Ansible for orchestration. I'm able to store that state and I can access it from any point in time. So I may deploy initially on my local laptop, but maybe another one of my team members is using Cloud9, the AWS IDE, to do their development and modifications. We can both share the same state information using an S3 bucket. You can also do state sharing through GitHub, through Terraform Enterprise. There's a lot of different ways, but this really kind of takes it to the next level and allows us to work in a much larger team. The ability to taint certain components of your infrastructure without redeploying. So what do I mean by that, right? So let's say that I have deployed my infrastructure. As you'll see in this demo, there's a lot of things that are happening, especially inside of AWS. When I change my big IP configuration, I don't want to go redeploy everything, right? Maybe I'm just changing the name of the app or the port the app listens on. And so tainting gives me the ability to say, hey, Terraform, just change this component. Don't touch anything else. And so to me, that's very powerful because I can quickly iterate through development processes without having to rebuild all the time. Now, Terraform is maintained by HashiCorp. It uses a declarative approach, which is one of the things that we like, and it uses a push method, another thing that we like. Now, it's written in Go. A lot of your other automation tools are either written in Ruby or Python. This is really nice because I know some of you, like myself, you're trying to learn Go. It's a great way to go to the Terraform providers section on GitHub and see how some of these providers are written. And more importantly, it gives you some use cases you could start with, right? You could actually start writing some add-ons to open source for the Terraform providers, such as F5. So let's dig into a little more information on Terraform. So there's a couple of commands that we'll use. By no means is this extensive or everything that's in there, but Terraform init is how we're going to tell Terraform to download any of the modules that we need to get our code up and running. Terraform Plan, we talked about earlier, tells me what my environment will look like, what things would change. Now, we are doing a live demo today, so I have already deployed the environment. So when we do a Terraform Plan, you're going to see Terraform say, hey, there's no changes. But that's OK. In your environment, you would do the apply. It takes anywhere from 3 to 5 minutes, hence why it's already deployed for us. Now, Terraform Apply does what we think, right? It applies our changes on a brand new install. It would deploy all of our infrastructure. There's also the ability to do output. So one of the things I have it doing is telling me what the IP address is of my F5, what my password is. Because these are ephemeral environments, I actually have Terraform generating the password and then storing it in the Terraform state files. This is an ephemeral environment, right? This is more like cattle, not a pet. So I don't necessarily would store or set a common F5 password across the entire environment. I let Terraform manage that for me. And then Terraform taint, we mentioned, allows us to taint particular components. And then destroy, it wipes everything out, right? So this really is a cool way to be able to stand up an entire lab and then tear it all down as soon as I'm done. And this has allowed me to do a lot of really neat things in AWS, such as test out particular use cases and then tear it down, right? I can be up and running in under 5 minutes in a lab, a simulated lab environment, without what would normally take me about 30 minutes to deploy all this manually through the AWS CLI or through the console. So for more information about Terraform, I'm linking the Linux Academy again, but they have some really good resources, and I particularly like their Managing Application and Infrastructure with Terraform course. If you're not a member of Linux Academy, they have a 7-day trial. Go check it out, see what you think. There are other resources, of course, but this is a good one that I liked. Let me come back to the modules. So to make things easier, I did not write everything in a single Terraform file, right? This would be hard to read, especially for beginners. Instead, I wanted to really break it out. So I have a big IP module. Essentially, that's a folder that contains information that allows us to deploy the big IP EC2 instance. And then that allows us to do things like configure declarative onboarding and configure our application through AS3. I'm also deploying a separate compute folder or module that does our EC2 instance. Now, there is a module for IAM, or access management. Some of the things I'm doing in there aren't required for this particular lab, but it does set the framework for us to be able to do things like clustering or service discovery with AS3 for future exercises. And then networking is doing some of the things we would expect, right? Building out the VPC, setting our subnets, setting our security groups. And we'll take a look at some of this in a minute. Now, variable interpolation is a key component of Terraform that allows us to tie a lot of the modules together. Now, when I'm calling or building out the ECS instance, and then I need to use those IP addresses in the big IP, I have to use an output file to send the data between the modules. And the way I'm able to reference some of that is through variables. Now, in some of the intro classes, you'll see that the variables are coded directly into the main.tf file. Then you'll start to see where variables are broken out into the variables.tf. Now, this may look confusing because here's the variable defined, but the definition isn't there. The reason we do that is that the variables are actually in the terraform.tf bars file. This allows you to separate the variable definition and what type it is from what the actual value is. Now, in the example provided on the slide, there's really nothing sensitive here, but you could be storing things like passwords, or if you're not using the AWS CLI credentials, you may be putting your actual access and secret keys into the TF bars file. And these are things that would not get checked into your code repository. So we can use interpolation in either the Terraform or JSON syntax, and it's wrapped in the $curly brackets. So the example we have here is showing building out the AWS VPC. And what we're doing is defining the CIDR blocks from our variables. You'll notice here that the VPC CIDR is defined here, and that there is an actual value set in the TF bars. Now, there's more that you can do than just variables. You can also use attributes from other resources and call functions and much more. Now, the attributes from other resources is important because if I am setting an IP address, let's say in my ECS cluster, I don't want to store that and then change the variables, right? I really would prefer to reference the module itself, because that way if the module changes something, all of a sudden it changes everywhere else. This is a lot more powerful because we want to move away from the potential that I could have human error where I've set the or the module has set the variable and then I am reassigning the variable. Just reference the variable to begin with and it'll cause you or alleviate some pain in the future. So what are requirements to get up and running in the lab today? Well, we need to have Terraform 11.13 or higher. And that's just simply because it's what I've used for these labs. It's not to say it may not work with earlier, but I have not tested it. Big IP 13.1 is required because we're using declarative onboarding, and that's the minimum version of TMOS to do that declaration to configure things like licensing and networking. I am using the AWS CLI, so this is how I'm getting my things such as my access and secret keys. If you would prefer to not use the CLI, then you can set those as variables. However, this is where you'll notice Terraform isn't at a .1 release yet. This is one of the areas where I kind of prefer Ansible, because there are some times that I'm having to fail down to a command line and actually execute AWS CLI commands or curl commands against the big IP. Now, that's not to say that's Terraform's fault, right? Part of that is the providers like F5, right? We've got to catch up. We've got to enable more functionality, such as actually giving you a F5 provider that does things like AS3 or DO, and those are definitely in the works. But I am using the AWS CLI to do things like pull the private IP addresses of the ECS instances. And this is because the AWS API does not return those IP addresses by default. I'm also using the AWS CLI to determine when the big IP on initial boot is actually ready to go. So this gives me the ability to hold off my AS3 and DO declaration posts until after the big IP is ready to receive them. So let's just jump into some demo code. I'm going to switch screens, and you're going to see a lot of mess here for a second, but I'll switch over to the code itself. All right. So what we're looking at here is my VS Code. What I'm showing, let me actually go to main.tf. So this is something that may look familiar. We've shown an example earlier where we were calling a provider and a method and doing something with it. Now, the one I'm showing you right here is the big IP. I mentioned before I have things broken into various modules. What I'm doing here, though, is I'm looking for the F5 AMI. Instead of hard coding the F5 AMI, I'd much rather go find it. So this is our unique owner ID. This can be found by looking in the marketplace if you look at some of the metadata. And I am specifically looking for a AMI that is a 14.x deployment, but that PG. So if you would prefer to switch away from PG to another one, just go to the AWS Marketplace and make sure that this value matches what you see there. Now, the wildcards basically allow me to say I don't care about the .0 to 0001 that's out there today, or .0002. And I'm just looking for anything in between the period and then when the PG shows up. And again, I don't care anything after the MBPS, right? Just kind of makes it easier. I'm also setting my random password. So this is a built-in function inside of Terraform. I can override special values. I'm just setting the @ because F5 doesn't accept all special characters. And so, you know, in your production environments, you may make this a little more strict, but this gives me a way to build out my environment and make it pretty easy to just let Terraform manage the passwords. So let's actually look through some of this, right? I mentioned before, let me clear the screen. We need to do a Terraform init. And so this is going to have Terraform start downloading the modules that we need. Notice that we're using a couple. In our environment, we're using networking, IAM, compute, big IP. But there were also modules that we needed inside of the Terraform providers, such as AWS, external, HTTP, null, random, and template. So once we have all of that up and running, we can now do our Terraform plan. And Terraform plan is going to tell us what would change in the environment, right? So when initially, you would see Terraform state that it's going to deploy a lot of new services, things like our AWS environment and things like the big IP. So it's because I said earlier I had to build this out so we weren't sitting around for 3 to 5 minutes waiting for it. There's nothing that it needs to apply, or there's nothing that would be built. But we'll go ahead and run our Terraform apply just so you can see that process, and more importantly, see the output. Now, these output variables are customizable, right? I'm just giving you this data so that you can easily log into your big IP. We'll let that finish. So you'll notice what he's doing is Terraform is actually running through to evaluate and refresh the state. Some of the components are actually computed. So things like my IP address is computed. Now, when we get into our big IP, we'll see that the password is set here. And I'm sorry, the IP address is set here, and my password is here. I also have my private IPs of my ECS instances on the screen as well. This just helps me troubleshoot so that I can verify that everything was set up correctly. And if I want to see if the environment actually deployed, I can do a curl, HTTP, and I get back my test page. And so in this environment, some of the things I may want to look at are things like the state. So we can do a Terraform state list. And this is going to show me all the individual components that Terraform is storing. So for example, I may want to figure out, hey, what is the IP address that Terraform is locking down my environment to? So if I do a Terraform state show, and then I copy this information right here. I apologize if you can hear that. They're mowing outside. So in this case, this is where my public IP address is, how I'm pulling that. AWS does have the ability to tell you what your IP address is, but it doesn't actually return a valid HTTP object. And so Terraform doesn't like that. There again, little things that just have to be updated as the product starts to reach a 1.0 release. So we've curled, we've shown that the output is what we expected. Let's kind of take a look at what we were configuring here. So if I go into my big IP module, some of the things that we did was declarative onboarding. So what we're looking at here is a template file. And realistically, this is JSON, right? This is a JSON payload. And I'm setting things like my host name. I'm setting my name servers. I'm setting my DNS search strings. I'm setting my NTP. And then I'm provisioning the various modules that I want in my environment. Now, yours may be different. You may want to add on some application security. You may want to use your own DNS servers inside your AWS environment. And this gives you that capability. If you're unsure of what things are available through declarative onboarding, I highly recommend that you check out the F5 Cloud Docs website. That's clouddocs.f5.com. And there's extensive information and examples on how to configure DO. Now, in this particular use case, there's no variables that I'm overriding, right? These are all things that I'm just hard coding, but we do want to start using things like templating, right? And this is where we can get into AS3. So what we have here is an AS3 declaration. And what we're seeing is the various components. So I'm deploying a sample tenant. I'm deploying an HTTP-based application. Now, this right here, that interpolation, right, that I'm pulling the public IP address out of the template. So this is something that's actually being stored in my variables. Now, if I go back over to main.tf, and I'm going to look for my section that's building out the template for the HTTP app. And here we go, this section right here. I'm going to de-highlight that so you can read it. I'll make it a little bigger. What we're doing is we're pulling the public IP address from the module that we've already instantiated earlier. So that AWS instance, F5 big IP, and the private IP is something that's being stored. So if I was to do a state lookup on this, so let's do Terraform state show. And nope, it's not going to work for me. Let me try one more. I may be doing that incorrectly. There we go. So we'll see that I have a private IP defined, and that's a variable that I can access. Well, this is nice because this gets updated every time I run my code. I'm not setting this statically. Now, my workload IP addresses are pulled in from another module. So in this case, we're actually pulling these variables in from the compute workload. And they're coming into my big IP module as a variable, which is workload IPs. Now, they're coming in as a map data type. So I'm pulling out the IPs from that map. I'm then splitting them so that I can actually do a format because the JSON needs to have strings around it. And then JSON encode builds an object out of that. So it gives me the correct formatting that I need inside of my AS3 declaration. If you notice here, we're doing the interpolation again, I'm sorry, down here, we're doing the interpolation again. But if you were to actually look at the schema, server addresses must be an array. And that's what one of the things the JSON code here, sorry, the JSON code is doing for me, is it's building it in the correct JSON format. Now, this is probably a little more complex demonstration than you would want to get into. These are some of the things that hopefully we can start to abstract out for you as we add more capabilities into our Terraform provider. Now, what this is ultimately should be building is a virtual server with the public or the private IP address. Sorry, I need to change that variable name. And then the individual workloads. So if I come back over and I pull my password, oops, and I just messed that up. All right, let's come back up. Here we go. So here's the password. I'm not worried about any of y'all logging in because it should be locked down. And it will be deleted after this. So we come in, we change partitions. We see that we have our sample one tenant. We see that we have our service main. It should be configured exactly like we expected. Nothing fancy here. We're doing auto map. If we look at our pools, we see that our web pool is here and that our members are the ECS instances that we built out through Terraform earlier. So, really, we were able to stand up everything from the infrastructure, such as our compute, our Docker containers, all the way through our big IP configuration. So let's actually take a look at, well, what if I needed to modify something, right? I want to modify my AS3 declaration. How would I do that? So this is where the taint comes into play. So I'm going to do a reverse lookup. What we have here is we're telling it to taint the big IP module, and the null resource is where we're calling AS3. This is where we're dropping down to a curl command, and then I'm going to tell Terraform to apply it. Now, I've got a couple extra things going on here. The ampersand just basically says run these two commands if the first one is successful. And the auto approve is telling Terraform not to prompt me to say yes. So it's up to you whether you would use these in production. It does make our life a little easier, but you may actually want to do the approve process. So we'll go ahead and hit yes or enter, and we'll see that Terraform is about to taint AS3, which means that it will reconfigure or redeploy our AS3 module. So we'll give that a minute, we'll let it run. And so what we're seeing here is the actual shell script that was being executed. The curl command is processing, waiting for its response. We'll let that run, and then we see our result coming back. Now, in this case, we saw it was successful, meaning AS3 was able to take the declaration and update the big IP. Now, because it was apply, I'm also printing this information out, but again, that's for my, makes it easy to do this in a lab. You're storing this data inside of Terraform state, so you can always pull it out from there. So with that, that's kind of our demo. What I'd like to do now is jump over to Q&A. So let me switch back, and we will open up the Q&A. So I'm going to bring Zoom back up. All right. So I see a lot of stuff in the chat, guys. If you have a question, like I said, please put it into the Q&A, because that's how we're answering questions. So we've got some time, plenty of time to answer your questions today. So please go ahead, and if you put something in the chat, put it in the QA, and we'll go from there. So I think the first question was, does Ansible use push or pull method? Ansible uses the push method, and at least that's how we primarily use it. I'm sure you could make Ansible pull, but its default method is to push. Ken asked, regarding Chef and similar CM tools, note that host-based CM tools are often focused on configuration within a node, not across nodes or within infrastructure. Terraform is more suited to the interactions between systems. That's a great point, Ken. And maybe that's one of the reasons why I like Terraform, because it allows me to think of it in a much larger aspect compared to Ansible. I mean, to be fair, I started with Ansible. It's what I've used for a couple of years now. Terraform is fairly new to me in the last couple of months, but it does give me a lot more, in my opinion, freedom to be able to build out the infrastructure and maintain that state no matter where I am. Because a lot of times I switch between my laptop, my iPad, and I switch back, right? And I don't have to worry about, well, where did I store that state and what state is it in, right? I can quickly run my examples. Let's see, Daniel, is there a reason we are using Terraform to apply an AS3 template instead of using the Terraform F5 Big IP provider? So yes, we do have a Terraform Big IP provider. It is capable of building out virtual servers, building out nodes, pool members, and all the different components that would be necessary to do some of the initial configuration. Some caveats, right? The provider is imperative. There's nothing wrong with that. And if you start with that model, that's fine. What I started to run into was limitations, such as when I have multiple big IPs. when I need to change nodes. And these are some things that I need to work on with that team. Is when we talk about things like the documentation, we show creating a node, but we're giving the name of the node like sample01. In infrastructure as code, I should be able to update my nodes without potentially causing a problem. And if you follow our documentation on Terraform for our provider, if you were to name that tenant or that node sample01, it will not let you update that node, right? So you really, in those cases, need to be naming the node, the IP address. So that Terraform provider was, think of it as it was our first offering. There's work that's being done around AS3 because it gives us a declarative model, a lot more flexibility. So I would say you'll notice that there is active development being done on that provider. And please do play with it. But I would tend to lead you towards AS3 and using AS3 to really start getting into a declarative API type of mindset. Let's see, what we call the JSON payload template. I don't know if you're talking about the declarative onboarding or the AS3. We're using both. So what happens is we're storing it as a template file. It could be stored as JSON. Terraform doesn't care. But we're using the variable interpolation to store or pull variables into that template. So this allows me to define the template inside of Terraform and then to say, all right, these two variables, right, the virtual server IP address and my workloads will be overwritten. Now, we don't have things like loops. It's not as powerful as what we are experienced with Jinja 2 inside of Ansible. And so I don't think there's anything wrong with using it for initial deployments, but if you have a lot of updates, you may choose to use both, and that's what we'll do in session 3. Justin asks, could most of this be done via CloudFormation using an F5 template from GitHub? I see in your templates for CloudFormation, it has an AS3 box and the stat creation. Would something in that be able to script out the creation of virtual IPs, pools, etc.? Possibly. There are, so the CloudFormation templates that we offer really try to cover the most common use cases. There's nothing that prevents you from modifying the CloudFormation template yourself. So Justin, in your case, you could modify the cloud init, because one of the things cloud init is doing is he is putting some cloud libraries onto the big IP. And we do have examples where we're using cloud init to add on AS3 and declarative onboarding. And you could even have AS3 and DO pull configurations from a repository all through cloud init. So you could definitely do it that way if you're just trying to get the initial on board. The reason I didn't do it in this example is I wanted to be able to show you the ability to taint. If I had done the AS3 and DO declarations through the cloud init, then I'd have to taint the entire big IP, and I don't want to constantly be redeploying it. But there's nothing wrong with doing it that way through cloud init. It's really what works best, pardon me, for you. Joe asked, does AS3 support I think I lost Joe's question. Oh, there we go. Does AS3 support non-LTM modules? Yes, it does. So AS3 does support other modules such as F5 DNS, F5 Application Security Manager. More are being added every month. So AS3 and the entire automation toolchain is part of our agile development processes at F5. So they do 2 sprints. The sprints are typically 2 weeks long, and they release at the end of those 2 sprints. So we're always adding in new functionality and new features in that environment. Yeah, Ted, did you want to add something to that?
I was just going to mention one thing about AS3 also is you can reference like data groups and iRules and certificates from other sources of truth. So you can just pull those into your template and store them somewhere else.
Yeah, absolutely. And maybe that's a good follow-up, right? That we could do another webinar or a live stream just more dedicated towards AS3 that has been requested. And so, thank you, Joe. We can definitely look into that. Let's see. Going through these, give me just a second. What are the CI/CD pipelines currently supported or use cases in F5 deployments? So F5 itself does not write a module for any of the CI pipelines. Instead, what we're doing is we're showing examples of using the CI pipeline's API capabilities to make the API calls directly into the F5, or we're typically relying upon things like Terraform or Ansible that's being called from the CI pipeline. There's a couple different ways we can look at this. If we're really looking at pure infrastructure as code, where the developer or the SRE team is writing the AS3 declaration themselves, then there may not be a use case or a need to run through something like Ansible. Ansible and Terraform really at that point would just be standing up the big IP. They wouldn't be doing templatization around the AS3 declaration. And I should touch, we touched on that in the first webinar. I see a lot of NetOps teams looking at Ansible because it allows them to templatize the AS3 declaration, making it easier to jump into that, right? So instead of having to know how to build the JSON declaration, they're able to simply define a couple key variables, such as maybe the IP address and then the tag or the IP address is kind of what you saw us do there. I've worked with teams on both sides. So, for some of the teams I've worked with, they've used a GitHub module that was released open source that allows the big IP to tie into webhooks. So in that scenario, when the developer checks in an AS3 declaration into GitHub, then GitHub is sending a webhook to the big IP. The big IP is pulling out that information and reconfiguring itself on the fly. So while that's not a form of CI, right, that is a form of CD. So there's a lot of different ways that we could do that. We will definitely touch more on the CI pipelines in the next session, but for the most part, you should be able to play with F5 with any CI tool you use. We've done examples across Jenkins, Travis CI, Azure pipelines, many, many more. Dale said, great, any news on timelines to update the provider? I also did notice that the provider doesn't have the full feature set, i.e. no SSL profiles. So yes, that is something that's currently being evaluated. I don't have an ETA for you today. There again, that's one of the reasons we're trying to show you AS3 as well, because AS3 gives us the ability to move away from those imperative implementations. Some of you have heard me talk about this before, where when we look at, let's say, writing imperative methods for all the various components that we support, when we release a new feature, we then have to go write it into Terraform, write it into Ansible, go write it into Puppet, go write it into, you get the idea, right? And that doesn't scale. Versus when we use AS3, we're able to write a new feature in AS3, and all of those features or all those providers get that immediately. So I think what you'll see from us is you'll see the providers start to use AS3 and some more functionality added over time, but will probably be similar to what we're doing with Ansible, where F5 is moving more towards roles and not necessarily adding in more and more modules. What do you suggest for ServiceNow integration with BigIP, LTM, GTM for build, Ansible, or Terraform? I've seen examples where ServiceNow is making direct API calls into the big IP for configuration management. Now, mind you, that's typically what I've seen ServiceNow used for in the scenario that we're updating or deploying new applications. When we talk about full lifecycle management, yes, that's one of the areas I would recommend that we go towards Terraform or Ansible. Now, Ansible has Ansible Tower. So you could have ServiceNow call the API in Ansible Tower. On the other hand, I've seen a lot of people going down the path of ServiceNow interacting with a code repository like GitHub or GitLab. I kind of like that method because GitLab or GitHub, the code repository becomes the source of truth. And it allows us to work with multiple work streams. For example, some of your DevOps teams may despise ServiceNow. They may not ever want to go through it. And if we only had the integration between ServiceNow and the big IP, then we'd have to repeat that process for our development teams that are going natively against a code repository. When we use things like a CI tool with a code repository, now everyone can come in through that CI tool and be able to have an app that results in the same process. So for me, from a troubleshooting perspective, that makes life easier for my teams so that we know all apps are being deployed in a LAC manner. Chris said, REST API versus JSON versus AS3. Difference, pros, cons. Is there a way to have an AS3 reference common partition? So let me touch on the last one. The reason AS3 does not deploy into common by default is we wanted you to be able to deploy AS3 automation in an existing environment. Now, that being said, AS3 does have the ability to write objects into common, right? It's not by default, but you do have the ability to override that. I would recommend that you don't, right? This is where we get into like a greenfield versus brownfield management capabilities. So AS3 is probably not the right tool when we're talking about managing a brownfield deployment. This is where we're doing like day 2 operations on something you deployed years ago or even last week. This is things like updating pool members. This is where things like Ansible modules or even possibly Terraform provider could be useful. I have myself have not played with that with Terraform. I typically do that with Ansible. So I would say that, you know, avoid common if you can. Where common becomes very powerful is when we have things like a Kubernetes ingress router, and that's a pool member. Well, because that IP address could be shared across multiple applications, we want to make sure that that's stored in common so everyone can use it. Now, you said in regards to REST API versus JSON versus AS3, I think if I'm understanding it correctly, right, we have REST APIs, we have AS3. Why would you use one or the other? Our REST APIs are imperative. So essentially what AS3 is doing for you is he's taking that first API call, that declarative API call, and then he's figuring out what imperative calls he needs to make on the back end. You're giving us the ability to do that domain-specific knowledge. So give you an example. Maybe you upgrade to 15.1 next spring, or you need to go through all your regression testing again. If we're deploying with AS3, F5 has already done that testing for you. We guarantee that if the declaration deployed on 14.1, it will deploy again on 15.1, depending upon what schema version you're using. This is part of a schema contract. Versus if you were doing the REST API calls yourself, then you would have to be responsible for that. I hope that kind of helps there. What about PerApp LTM? So Reza, what's happening here is the PerApp is really just a licensing. So you can do automation against a PerApp just like you would a multi-app. The difference would be is that a PerApp, from a licensing perspective, would limit you to 3 virtual servers and 1 virtual IP address. So the demo that we're using today absolutely could be deployed on a PerApp. If, however, you had more than 3 virtual servers defined inside of your declaration, then when you make the API call, it would fail, right? Because it exceeded the licensing capability. Sharon said, why is a new partition created when creating a new virtual server? Can you create the virtual server in the common partition? I think we touched on this a little bit already, but the goal of AS3 is to be multi-tenant. And this allows us to help deal with collision domains. It helps deal with when we talk about automation. We really want to be multi-tenant in our automation stacks. But yes, AS3 does give you the ability to write into common if you want to. We do recommend against that, though. And Ted, are there any that we missed?
No, there's a couple we answered earlier in the chat, but I think we covered most of them. Okay. If you want to just have a quick look there, but.
Yeah, so there was, what is the major difference between Ansible playbook deployments and AS3 declarative onboarding? What would be the best? So I like this, Ted. Ted said, think Subway versus Jimmy John's. Ansible is similar to walking up the subway and answering a dozen questions for a sub. AS3 is like walking into Jimmy John's and just stating, I want a number 5. And your sub is produced without telling the employee what to add or remove and what order. Ted, I am totally stealing that example. I love that. Alex asked, are there plans for automation of IAP templates and services with stuff like Chef? Today, we use the REST APIs to deploy both in our IAP templates and services and let the operator teams take control of their own environment once they have been migrated to this kind of setup. Ted answered yes. Give it a few minutes and let's Cody discuss AS3. So I would say stuff like Chef, you're probably not going to see us write specific implementations into Chef. And one of the main reasons why is I mentioned before the imperative process of us having to write features into everything that's out there, every automation tool that's out there. We would much rather direct our partners and our customers to using a declarative API, because now we get away from, to Ted's point, ordering a Subway sandwich, right? I instead just want to be able to tell you what I want and not have to worry about, does that module exist? The example mentioned earlier by one of the attendees was the SSL profile not being available in Terraform, right? These are things that could be a showstopper. So AS3 allows you to be a lot more flexible around that. Greg asked, does Terraform only work for AS3, or is a tool that can be used on something like ESXi? Yes, Ted answered this, but I would tell you Terraform is meant to be agnostic. So we have examples of Terraform working in Azure. We have examples of Terraform working against ESXi. So yes, Terraform's goal is to try to help you deploy a like environment across any of your data centers or public or private cloud. So we got about a minute left. Everyone, I do appreciate your time today. I'm going to, of course, send out an email. It will go out within 24 hours. It will contain some of the information you see here, but the session 1 recording is available on YouTube. Session 2 code and slides are available on GitHub, and I will also post the recording for this later today. And then session 3 registration link will be provided to you in email, but this is where we're going to do kind of tying it all together and really digging into integrating with CI pipeline. So with that, I appreciate you attending today, and I hope you found this useful. If you wouldn't mind, fill out the poll for me. It's just a post survey. It helps us understand whether this was on topic for you, some of the things you did or did not like, and so that we can adjust this to meet your needs. So with that, I will go on mute, and thank you for your time today.